तो दोस्तों शुरू करते हैं without wasting a time. In this video, we are going to discuss about the ISIS Intermediate System Protocol. It's in a link state routing protocol as OSPF, and it's commonly used in the service provider network. Okay, and we can also can say that it's in a TLV based protocol, and the reason behind it with the help of TLV, it's easy to add for the support for the new feature or for the new requirement. Like one of the example we can take in the ISIS is with the help of TLV, we can easily create the support for the IPv6, correct? In the ISIS, there is no separate process is required to support the IPv6. Unlike in the OSPF, we need to define a different process to run the IPv6 OSPF v3. ISIS have a two type of level 1 and level 2. Okay, if area ID is same, they can form the L1 L2 neighborship, and if area ID is different, they will only form the L2 neighborship. So these are the few urgency requirements mentioned here. Interface M2 must match and area must be matched if L1. System ID must be unique and authentication must be succeeded. These are the MAC addresses which ISS use HSN2 protocol in the discovery on the ISS hello. When we configure ISS, we need to define a net ID. Net ID is a combination of your area ID, system ID, and selector. So these are the system ID should be unique. I mentioned earlier, if area ID is same, so they will form the L1 L2 neighborship. If this area ID will be different, they will form the only L2. One of the command you will commonly see the no hello padding or hello padding disable. So what the meaning of hello padding is? By default, IS will pad the hello packet. When IS send a hello packet, it uses the full interface MTU. So what is the use of hello padding? This is the use to detect the MTU mismatch or MTU on the either side the link should match. So one of the more command you will find in the config in the metric style wide. What is the use of metric style and why it's required is like in the OSP we do the link metric calculation with the help of bandwidth, but there is no such mechanism and there is no such automatic calculation for the ISS. In the ISS, link metric by default is 10, and by default maximum loud metric for each link is 63, and total metric is 1023. So this metric value is insufficient for the very large network. So that's the reason we need to configure metric style wide. Like in the case of, we can take example the traffic engineering. So let's see one by one thing, each thing in action with the help of configuration and with the help of ISA capture. First, we will configure the ISIS. We'll verify how to configure the net ID. Okay. After that, we will test these things. If area ID is same, they can form both names, L1 and L2. If area is different, these are the things we'll test. Okay. And after that, we'll check the hello padding, how we can disable this. Okay. And also verify these MAC addresses in the ISS hello packets. And also verify that metric style by. Let's jump to the configuration. So this is the topology we have in at present. I have shut down all the interfaces, so we are only going to check the router 1 to router 2, this gigabit 050 interface ISS never set. That's it. And loopback is configured on the router 1. Loopback 0 IP address is 1.1.1.1. On the router 2, loopback 0 IP address is 2.2.2. So we can see that this physical interface gig 0/0/0 and loopback 0 is a part of the ISS. Let's step to the configuration. So here we on the router 1. So let me quickly show you the configuration. So router ISI, this is the IO6 box. Okay, this is here you can see that this is the router ISS process configured, and this is your area ID, and this is the system ID, and this is the end selector is the always in the 0, and this is how you call the interface in the ISS in the IO6 platform. Okay, so as of now, if you see the status, only single interface is up. Okay, rest are down. You can see that. So this is interface down, this shutdown, only this 0/0 which interface connected with the router 2. Which is the neighborship, it will show this have neighborship with the router 2. Okay, so to verify the few parameter here, let's do the show ISS database to workouts. Okay, so I'm putting the show ISS database, then I'm putting the system ID, this number, and I'm putting the workbox. Okay, so this is how you can see the database on the router. Okay, and so at present router is forming a two neighborship. One is from the IS, one is from the level 1, okay, one is from the level 2. So whenever the area ID is same, so router will form the both L1 and L2 neighborship. So this is ultimately waste of the resource. Okay, as the router have to maintain the two database. Okay, one is for the level one is for the level two. Okay. This is here you can see in the ISS urgency command, which will make the one neighborship for the level one with the router two, one neighborship with the level two, the router two. Okay, so database, run the command. This star means this is showing the local LSP. So this is the LSP ID, where this is your first number is the system ID. This is the pseudo node, and this is the LSP is fragmented or not. Okay. This star means this LSP is locally generated. So this router one has generated this LSP, and those two LSP we are getting from the router two. Okay. And if you want to check for the detail for the particular LSP, show access database, and you can put this LSP ID. Okay, and after it will the detail. So which what are the things it's sending in under this LSP. So under this LSP, it's sending a these two prefix. One is the loopback 0 we getting from the router two. Another is the interface IP address. This slash 30 interface IP address is configured. Okay. Again, as it's making a two neighborship for the L1 and L2. So in the both L1 and L2, we're getting the similar detail. Okay. So this is LSP2 for the L2, and this is for the level 1. Okay. And if we have to change it, so how we can do that? Let's see. Okay. As we have to make the L2 only, so we have to undergo to the router ISS core process, and here we can make the ISI level 2 only. Because the core router, we have to ultimately put this. So I commit it here. Let's do the similar change on the router 2 also. Let me do that quickly. Show ISS urgency. So you can see that now we have only one level with the level 2. Okay. And if we check the database, the these are the three bits coming attached with P bit and O bit, which we'll cover later. So as of now, this is how the database looks like, and you can see the database for both and the command. Look for the detail under the what is the content in the each LSP, and these are the few LSP sequence number. LSP sequence number should match on the every router. Okay, okay. And some of the problematic scenario you can found that this sequence number mismatch. Okay, that can be the one of the issue to dig further. Okay. On the iOS XR, during the troubleshooting, you can run this the other command. Let me run some troubleshooting command like show ISS interface. This is my interface which you connect with the router to. So I'm checking the ISS detail on this interface. Once you run this command, so this will say urgency formation is enabled. Okay, if you're running a BFD, it will show BFD is enabled or not. Okay, level 2 only circuit is there. Okay, and this is here you can find the CLNS MTU 1497 is switching protocol status is up. Okay, and so these are the things you can check. Okay, and one of the command is show ISS all. Okay, when you run the command you get the multiple detail like here is showing the core processes, system ID for this router is this. Okay, this is the main area ID is configured. So we have configured both of the things that become the net ID as you can see in the configuration. This 14.129.0 dot after that then dot 0 and selector. Okay, here it's showing the matrix style which we discussed why we require a matrix style. So at present matrix style is narrow. Okay, we discussed about the matrix style why is required. So at present it's generating and accepting is narrow matrix style. Okay, so metric is showing 10. Okay, there is no prefix. Okay, it's showing the advertise passive prefix only. No distance is showing the AD for that. So whenever do the matrix style change in the configuration, that should be changed on the both sides. So matrix style type should be same on the both sides. If there will the configuration mismatch, you can stick with the problem like that. The route available in the database, not in the routing table. So let's see here in the ISS all we can see that matrix style is narrow. In the router 2 also matrix style is narrow. Okay, let's change it, switch to matrix style wide. What will happen? Let me show you. Let's we verify the routing table. So we have in the routing table, we have a loopback address for the router 2, and if we do the ping, so we have a ping which will confirm we have an this IP address also on the router 2. Okay, so this is the configuration we have now. Okay, to change the matrix file narrow to wide, which is mostly you see the implementation practical. Okay, so in the address family you have to go. After that you need to type a matrix style wide. Okay, once we do the commit here, okay, so now what we'll see, you will not get the route in the routing. You can see that now I have changed the matrix style. Okay, so this earlier loopback of 222 were in the routing table, but now this is not in the routing. The reason behind that, matrix style is not matching on the router 2. Still matrix style is now. While we take the database, show ISI database. Okay, and let's check database for this router 2. What are the LSP I'm getting from the detail here. Okay. Here you can see that in the database I'm getting the route, but in the routing table this route is not available. This is the one of the problem you can face during the troubleshooting or sometime when the configuration is smashed. So now what we have to do is let's jump to the router 2 to make the weighted style wide. As we have changed the metric, if we now run the command show as all, so here you can see that it's saying the metric style generated and accepted with the only wide. Let's check similar with the router. Here in the router 2, let's check the IS all. Here it's in the here accepting only metric style narrow. This region now you will also see the route also. Here also there is no loopback route for the router 1. So what we have to do is we have to do the configuration of network style wide. Okay. Change that one. The address family we have to go. After the metric style is wide. Let me do the commit. Once you do the commit here, you will be able to see that. Okay. Now we have so this is how you can disable the padding. What you have to do under the ISI router size 4. After that, you need to go to the interface level. Here, you will do the hello padding disable. Okay. So this is how you will disable the hello padding. And here you can see that in the ISS hello packet I'm checking. In the Ethernet header, here is the destination ISS for level 2. For the level 2, this is the MAC address 0180C2 0015. In the case of L1, here in the place of 15, we will the 14. Here in the Wireshark, you can see the detail about the TLV also. Okay, I have kept click on the LSP packet. Okay, so this is the packet number is frame number is 102. Here you can see, okay, in the 102, this is the LSP packet. The LSP packet under this link protocol PD unit. Okay, here if you come down, let's select it here. Okay, now so here we can see that for this IP interfaces. Okay, this TLV is 132. This is the length and this is the value. For the reachability is reserved. Okay, for the IP internal reachability, this is the TLV. Okay, for the host name, this is the TLV. TLV number for the host name 137. Interface address is advertising a loopback address here 132. Reachability is reserved internal. Is internal reachability is telling the loopback address also and telling the your interface address also, and they are supported what is the default metric also. So there are for each feature, for each prefix or each feature, you can say there is a different TLV and their number. So at present, this is the configuration we have on this router 1 and router 2. Okay. So we have this net ID where area is 49.192.0, here also 49.192.0, and there is the unique system ID. Here is the 168.0.0.0.0.0.1. Here is the 0.0.0.2 in the last. So it's in a unique, it's in different. We have already seen that with the same area ID, both router will form the both L1 L2 neighborship, and we have changed this to IS type level 2 only. So now there is only one neighborship. So let what we'll do, we'll configure this same ID. Let's change this same ID from last equal to 1. then the system ID is what both the routers see. Let's see what the problem will happen. So here I'm the router 1, router 2, sorry. So let's change the system ID to router 1. It is system ID. What we have to do is instead of to change system ID, first we need to remove the old system ID. To do that commit. After that, we need to put the new system ID. The new system ID is 1. So this is the system ID on the router 1 also. We need to do that. So this is also change that. System ID received. Coordinate LSP system ID on the interface. This. Okay, please check it for second only on the phone. So once you do that, this is the problem we'll face actually. In the logs also, it will say that receive self-coordinated ID with the system ID. So this kind of message you will get. So here is in the ISS duplicate ID, duplicate system ID. So you can fix that one. It's telling this is already used by this router in this. Telling the interface also from where it's getting. So you can easily identify. So let me roll back this thing, roll back on. Here are the multiple important bit in the ISS, like the overload bit, attach bit, and down and up bit. Okay. Let's start with the attach bit first. Attach bit is L1 router use attach bit in the L1 LSP to find the nearest L1 L2 router and use this as a default route to reach the closest or nearest L1 router. What do you mean that like in this topology we have in this success route is the L1 only. So this router is making this L1 L2 route in the L1 neighborhood. Okay. Once this router will receive this route from the L1 L2 on that LSP in the database, it will see the attach bit is set and this will install as a default route toward the nearest L1 L2 router. So on this access router, when it is the routing table, so there will be the one default route which will be providing towards the L1 L2 route. There is one problem with that adbit is it can create a suboptimal path. Like you can suppose we have one scenario and one more router here that is also L1 L2 router. So we have a two L1 L2 router or both are connected with this access router. Okay. Let's suppose this link is gigabit Ethernet and this link is below one link is 10 gig Ethernet. So there can be the scenario where this access router, okay, find this another route is the closest, but that path is not optimal. So attach bit sometimes can create a suboptimal path. We have an option to disable the, or we can say to unset the attach bit. We will see how we can do the unset attach bit. And but after disabling the or after doing the unset to that activity we need to propagate a route from the L2 to L1. So what happens in ISS by default your L1 what are the prefixes on this router they will automatically go to this L2 domain but from the route from the L2 domain will not by default will be propagated in the L1 domain. Okay, by default that HBD is sent and default output is all that why communication L2 and reachability is received. But once one set that HBD, we need to propagate on this L1 at the router. But we'll do under the router access process, we can do the propagate route L2 to L1 with the route policy. When you do the propagation on that time, ISS set a down bit. Okay, so with the help of the down bit, was let's suppose we have on this aggregation router 2 on this router. Let's suppose our loopback address is 100.100.100. So once this L1 router will pass this prefix to L1, so it will set the down bit. Okay, and once this router advertise any prefix, this will attach the up bit. So with the help of up and down bit, ISS prevent the loop. So this is the you can the loop prevention mechanism. There is a loop prevention mechanism implement like this. L1 router will set the up bit set advertise eligible for leaking. L1 router with down bit set are already leak and not leak back to the L2 area. L1 L2 router set down bit during the leaking. So this router will set the down bit during the leaking. If any prefix receive the down bit, the loop provision will stop them. If any prefix whoever down bit is set, that will not be further advertised. Leak router displayed in the routing with the intra area, IE flag will be set. So we'll see once we do the modification or the propagation. Let's first verify that this default. What happening is now we have on this IS type L2. We already confirmed three routers. Okay. I will quickly show the aggregation router 1 configuration and access router 1 configuration, then we'll do the verification command also, how we are seeing that active. So here we have the aggregation router 1. Okay, let me quickly show the configuration. Show run router I have had. Okay. So we done a one leg with the access router 1, which is the L1 type neighborship. Another leg with the core router, which is the L2. Okay, so this is the L1 L2 router. The normal configuration we have, this is the net ID system ID configure, and this is the interface we have called. And if we take the show ISS database, okay, as this is the L1 L2 router, so it's having a both of data L1 database and L2 database. Okay. Here you can see that it's attaching a in the O1 LSP star image O1 aggregation burn. This is the LSP of this local router. With the host name also we can identify. And here in the first bit ATT, this attached bit is set. We do the verbose for this. So as database, go and this verbose, where you can see that this attached bit is set and it's sending the these are the prefixes. Okay, so let's go to the aggregation router. Sorry, access router. So here we have the access router. Okay, so let me again show the neighborship. It's having a single neighborship with aggregation router one, which is the L1 type. Okay, and if you do the ISS protocol, run the command. In this command also you can get the details like manual area ID, your system ID, what is the network style, okay. And if you do the show ISS database, here you can see that which is set while we checking the routing table, so it's installed the default route. And this default route is pointing toward the this our L1 into router. As this is the only one L1 into router and this is the closest one, is we have put the route toward this one. Okay. So this is how attached bit work. But main problem with the attached bit is only is this can create a suboptimal path. So during the practical implementation, the live scenario, you can see that most of the time attached will be disabled. They will be propagating the route from the level 2 to level 1 and doing the changes during the configuration or with the help of tag we are attaching. So here we on the aggregation router is the L1 L2 router. So let's disable the attached bit set and do the propagation. Okay. I have configured this RPL which I am going to use during the propagation. Everything is passed, nothing in the RPL. So we have to go to the config IFS process address family IPv4 unicast under that we need to set here attach bit and then we need to propagate this route. So here we are disabling don't send the attach bit while sending the advertisement. And here we are propagating the route level 2 to level 1 and we are attaching the RPL which is shown. So let me do that for me. We now verify the again database. So now we will not see the attach bit here. Using the attach bit, there is no attach bit. As well as the same thing in the access. So here we on the access router as we have done the configuration on the aggregation L1 L2 router. So now there should not be any default route. Here you can see that now we don't have a default route. Now we have a specific route which are coming with the IA inter area flag which we have seen. Okay. To check the up and down beat as I use for the loop prevention mechanism, I have created the one loopback 100 whose IP address about the 123.123.123/32. Okay, and I'm taking the wireshark capture on this L1 L2 router while this propagating a route toward the L1 only. So on this interface, I will take the wireshark capture. Let's see up and down bit set in the wireshark capture. I have selected this frame number 127. Okay, go 127. So this is LSP. Okay, under that in the next state protocol PDU, exchange protocol under that. They are extended IP reachability. Under that we have an each per fixed advertising going on. For this, which is the test loopback we get in the L2 domain, this down bit is set, while this is also going from the L2 to L1 down bit is set. On all these prefixes, your down bit is set. Okay, and while the prefix which you are receiving from the L1, there will be the up bit only here. So this is the prefix belong to the L1. On the 11 router side only up bit is set. This how. So once another L1 elder road is even the topology that will see the down bit, so this will not otherwise the back into the main to prevent the loop. So we have seen the attach bit and up and down bit in the action. Let's talk about the overload bit. So it's tell other route in the network not to use the edit transit router while sending data traffic. Value of overload bit can be one if not set at zero. Okay. So what does it mean that if we have to do some activity of any issue we are facing, ultimately we don't want any traffic should go via that router. We can set the overload bit, and sometimes you can see the overload bit can be help us with the sync with the other protocol. Like here is I put the configuration command when you're doing the set overload bit. So we have an option wait for the BGP. Like we know ISS converge fast as compared to BGP. ISS is fast, so we can set overload bit. So ISS before ISS flood all of the LSP route towards the neighbor routing should wait for the BGP to converge. In this case, also overload bit set. Otherwise, normally, if you're facing any issue or you want to put the network router out from the topology out from the network, you can set the ISS overload bit. Okay, so what we'll do, we will set the overload bit on the router 2. Okay, uh, and we will increase this metric here. Without overload bit, what will happen when we ping from this any trace route, any prefix from this router to this loopback, so this will take this path, okay, as we have increased the metric on this path. But after putting the overload bit, so while sending traffic from this router to this router, this will not use this router as a transit router. This will take the higher metric path. Let's see the overload bit in action. Here in the router 1, let's increase the metric towards the router 3. The config, router access prop 4, and this is the interface is going toward the router 3, 002. Okay, there, put the metric 1 second. Just do the trace route from the access to. So here we on the access router. Let's trace route this 4 prefix. Okay, show route. Let's trace route this 123.1.6, which is going from the router 3. Here we can see it's taking the 4 hop. Okay, so 4 hop is going to the aggregation 1, then router 1, and then it's going to the router 2, then going to the router 3. As we have increased the metric between the router 1 to router 3. Let's do the overload bit set on router 2. So let's set the overload bit in the router 2. Okay, so we are doing the process router as 4 set overload bit. Overload bit set, let's do the access again. So here we on the access router. Let's do the single trace route again. Now we can see hop is 3. Okay, it's avoiding the router 2. Show as database. This is how you can see in the database within the command show as database. We'll be setting the overload bit. OL this bit is set for the. So to get the fast conversion in the network, normally these are the things that we have to do. First, we have to detect the changes. Then we have to notify those changes, and then we have to find the alternate path. So in the ISS, we have a few commands we can configure to get the fast conversion, like max LSP lifetime or LSP refresh time. Okay, so max LSP lifetime it will reduce the control plane traffic and save the CPU usage, like LSP refresh interval. This reduces the LSP flooding frequency, peak utilization help. SP and SPF interval we can change when we are using BFT to ISS. For the partial calculation, PRC interval you configure. LSP generation interval you can configure. Prefix suppression is also one command where we suppress the interfaces IP address to the routing table. So routing table have an only loopback addresses. So this reduce the routing table size and ultimately get the fast conversions. In the ISS CSNP complete sequence number protocol data unit, we have in this LSP sequence number, there what the lifetime is pending, remaining lifetime before the LSP expires. This is checksum number. Okay. Another packet is the LSP. In the LSP packet, we have two important IRS reachability and IP reachability, which is for the RIB, routing information base. Like here, we can verify the IP extended field, all the prefix, which what is the beta set, what is the length is given.